welcome to our panel on the odd couple. How blockchains can help AI. So thank you for being here. I think maybe first we could start by a round of introduction. So Scott,
Absolutely.
Can you kick us off?
Scott Dykstra, CTO, co-founder of Space and Time, a decentralized data warehouse facilitated by Chainlink to get query results on chain.
Yeah, I'm Ron Bodkin, co-founder and CEO of ChainML. We're really focused on generative AI agents to enable people to build powerful functionality into their applications. Last year I was here at SmartCon talking about AI and crypto, and people were wondering what I was talking about. But you've all come around to my point of view.
Yep.
Alex Campbell, I'm the CEO of Rose AI. We're a financial data marketplace.
Right, Humayun Sheikh, CEO, founder, Fetch AI, background in, I think I was talking what you were saying last year, but 5 years ago, and the battery's probably dead. 5 years ago, and people were looking at me thinking, what is autonomous economic agents? Why are you even telling us about it? So here we are.
All right. Well, welcome. So let's get started with our first question. So how do AI and blockchain, how do you see them intersect in the next couple of years? And how do you see AI help blockchain and vice versa, blockchain help AI? You want to get us started?
Sure, I'll kick it off. I think we're seeing a lot of adoption of enterprises that want to train their own LLMs on their own private data. They don't want to send sensitive data over the WAN to OpenAI, for example. And as they do so, they want verifiability. I mean, you just talked about it so elegantly. Like, as they train this data train models from their own private data, they want some kind of confidence that that they've trained the model from a viable data set, and B, that drift and bias isn't occurring over time, that they're actually training this data in a verifiable way. So we see blockchain at the intersection of private training of LLMs in a verifiable, kind of cryptographically guaranteed way.
I'd say that it's a journey of adoption of AI for Web3, right? That in the Web3 community, suddenly projects are realizing there's so much power in what you can do with generative AI to improve your protocol, to improve your dApp, that often that's the first step. We were working with Space and Time to power their Houston chatbot with council agents that make it easy to do things like generate queries and even do forecasting and visualize results, or generate code for integration, right? So it's no secret that many Web3 projects are novel ideas, and sometimes it's hard for users to understand and be confident in what they're doing, right? So generative AI can be a real force multiplier for adoption. We think that's step one. Over time, people are going to get more comfortable with AI and say, hey, it's not just great at the dApp layer, but wouldn't it be great to start integrating it into our smart contracts? And when you think about it, a smart contract ought to be smart, not a dumb script, right? So AI kind of can fill that gap, right? So we think over time, you're going to see things going from hey, let's let people understand risk metrics, for example, for governance votes with AI tools, to why don't we start automating more of that? But throughout that process, I think it's incredibly important to retain the right level of governance and control. So making sure that people can have oversight and know what's going on, so that we give more autonomy to AI, but still keep people firmly in control. And I think that's an incredibly important part of that intersection of AI and crypto.
Yeah, I think there's a trade-off between the two, in the sense that smarter robots need more access to financial services, financial systems, and many that are automated. And so the old traditional financial system actually isn't the right pipes necessarily for this new AI future. And then on the other side, crypto generates an enormous amount of data that is very confusing, very distributed, very hard to parse. And so smarter machines should help with that, and help us kind of synthesize, look through, really clarify what's actually happening in the world. In a way that just the generation of this data actually provides a challenge for people.
Yeah, we take an approach of orchestration. So if you're looking at automation and you're looking at granularizing all this AI, and you're going to have all this group of people who are going to be participating in this new AI wave and bringing new models and data sets, you need a kind of an open orchestration layer. And we see as blockchain providing that bit. So if you're looking at autonomous agents, these autonomous agents need orchestration. They need a place to put their transactions, their data, what they did, what their auditability. I think blockchain does that pretty well. So we see blockchain bringing that element into the whole, this AI kind of drive.
Makes sense. So staying with you, Humayun, what role do you see collective AI play versus centralized AI?
Well, I think you covered again in your last talk. You covered exactly kind of that, which is how do we enable different people to come together and collaborate in building AI? And I think that's quite important. As you said, you don't want this to be just a property of a few few people who own most of the infrastructure. So to enable that, you have to provide model builders, AI builders to come together, and you need to provide them all the tools. And collective learning, as we call it, or collective AI, is just the beginning of that. And how do you then build it? How do you then monetize it? They're the two most important bits, because without monetization, you wouldn't see the uptake. Nobody would participate unless you can monetize. So collective AI, I think, is the future. Centralized AI is going to be perhaps more powerful, but because of obvious reasons, it's more efficient. But ultimately, I feel that even with centralized AIs, you probably would interact more with the open source and more with the collective side of it.
Makes sense. Alex, how do you solve the data mutualization problem with Rose AI?
Yeah, I think most people don't realize how much of finance is just finding, cleaning, managing, visualizing data. If global financial GDP is around 7 trillion, 1 trillion of that is just people running around doing that's part of their job, or entire stacks of folks doing that. And so we take an approach which is there's no perfect source of truth. There's different interpretations by different people that need their different domain expertise put on top, and that it's actually that kind of synthesis between the human and the machine in a very decentralized way that kind of gets you towards truth. If you go to the biggest hedge funds in the world, the biggest banks in the world, the way that they treat that information is pretty critical and pretty coming with that perspective of kind of what we like to say is don't trust the machine. You need to have multiple perspectives, you need to have multiple sources, and bring those together into your own version of truth, just knowing that it's slightly fallible.
Makes sense. And Ranj, you talked a bit about the Houston project. Maybe you could tell us a bit more about that?
Yeah, so it's a capability, a chatbot that's baked into Space and Time's DApp. And so we collaborated on this. It leverages OpenAI models on the back end, but really the key thing is how do you orchestrate to make it reliable, right? So how can you do things like make it easy to have a personalized Stack Overflow answer for developers using the Space and Time's protocol, right? So tell them exactly how do you write the code, and behind the scenes, it's not just go out and generate code, but then in a sandbox, simulate it, discover any errors, correct it. How do you prompt it with the right information up front to say, hey, this is the latest version of the API that you should use in generating the code, since OpenAI isn't up to date on the rapid pace of release of the software, right? So it provides functionalities like that kind of integration. It provides functionality like self-service analytics, right? So users can see the latest blockchain data. They can visualize it and ask to see it in different ways. They can do forecasting to say, hey, what might this mean for risk for the future, right? So if I'm doing a trading strategy, right? And so we think, it also provides, answers from your documentation to make it easy for you to say, hey, what's going on? How do I use this API? And give a concise answer that's authoritative, and even research, right? To look up from authoritative news sources what's going on more generally in blockchain, right? So we think that kind of building specialized agents to make the users of the app super productive is useful. I don't know, Scott, if you had anything you would add to that.
Yeah, that was well said. Space and Time's DApp is a sort of next generation blockchain data exploratory tool, next generation data dashboarding tool for finding the data you need, running queries, creating Chainlink jobs that put those query results on chain, and also building, kind of community public dashboards. And what ChainML did a really good job of, and I think they were pretty early in figuring this out, is that there's going to be a set of actions on the front end that users want to do that need to be routed to sort of different domains within an AI agent framework. Like some users want to write queries, some users want to create Chainlink jobs, some users, like a functions job, for example. Some users want to actually just write raw JavaScript that they want to then edit before they put into a functions job. Some users want some help with documentation or bugs. So the ChainML framework's the front end that sort of routes those requests to the appropriate backend services in a really low latency way. And I think like the simplest approach to this is the best approach in some ways of like just how fast can we get the routing done and then actually use AI agents.
Makes sense. Yeah, it's really fascinating to see how you're all working on different parts of that big puzzle, and you could start seeing that puzzle make sense and come together, and will just accelerate the whole really merging of those two technologies. So one other important part of the puzzle is ZK.
Yeah.
So what roles do you see ZK mechanisms like proof of SQL play in training and serving AI models to help build verifiable AI?
Sure, yeah. We try to think about the different parts of the stack. On the front end, we just talked about how ChainML can enable a better chatbot and a better chatbot experience. And I think we'll see a lot of novel dApps. We'll see the friend text of the world start leveraging AI for a more interactive, more fun experience in Web3. But then as you get down the stack, proving that something from the back end was returned to the front end in a verifiable way will be really important. And proving that off-chain but verifying on-chain like Chainlink does will be really important. Another part of the stack is like when we're actually training an LLM, what data are we training it on? We've been pleasantly surprised. Space and Time's gotten pulled into an engagement with a major cloud player in partnership with a top 4 auditor, in partnership with a large blockchain, and this weird but fun collaboration of these 4 companies that came together to say, okay, we want to define standards that the industry can use around what a valid, neutral, unbiased data set looks like, and then prove to the world, attest to the world on chain that a certain enterprise LLM privately was trained on that attested, neutral, unbiased data set. Think about things like loan origination. Was the decision to give Kamal a loan done in an unbiased way? And so like we've been pleasantly surprised to see that enterprises are thinking about this already. Of like, okay, I don't necessarily want to live and die on OpenAI. I kind of want to train my own LLM. Can I prove to my community, my constituents, my customers that the technology they're interacting with was trained in a neutral way? And then if we prove that somewhere, where do we verify it? Thus, one of the major blockchains got involved to run verification. So just trying to think about like the different layers of the stack where zero knowledge can be used to prove not just data that was used to train an LLM, but even the inference. I think there's some nascent Web3 ZK-focused projects that are actually building math around proving the inference of the LLM, not just proving the training. Space and Time's focused on training, but I'm sure some pretty brilliant folks will figure out the inference part.
I think it's important, though, to note that the overhead of generating proofs, even verifying them, can be quite significant, right? So, nascent projects that are saying, hey, we took Nano GPT, which is like, 1/10,000th the size of GPT-4, and it only takes a few hours to generate a proof. And then you multiply it out, and you're like, I don't think I can wait a month to generate, or want to pay the compute to do a month to generate a proof of a single model call. So, it's good for certain cases, right? Like fraud detection, where you tend to use decision tree-based methods that are quite compact. It's really quite feasible to have zero-knowledge proofs to say, hey, I can cryptographically guarantee that this model was used for your loan scoring on chain, or for guarding risk in this DeFi protocol. Like those scenarios, I think, will happen in the coming years. I'm a lot more skeptical that zero-knowledge proofs will ever catch up with state-of-the-art AI, because even as people build hardware and improve the zero-knowledge circuits, the AI industry is racing ahead, with exponentially more compute to build the most powerful models.
That makes sense. Before we move on, for the loan thing, it's easy. If they said yes to lending to Kamal, it's good, it's fair.
Yeah.
No, it's not fair.
There's a backdoor in the model.
It's like very,
binary.
if then else kind of AI, So Ron, you started touching on this, and ZK is this promise about like decentralization for AI. But in your mind, like, what's the journey for decentralized AI for the Web3 community?
Yeah, I mean, I think that it's really, there's been this realization that AI is going to be an important part of the stack, for Web3, and, this emerging realization that, the cryptography and security that Web3 offers can be really powerful for AI, right, to enable decentralization. So I think it's, the next couple years is about starting to build connections between the communities. So that means the low-hanging fruit of integrating AI into protocols and DAOs, whether it be through dApps or whether it be community governance tools, bots in Discord, enabling governance decisions, right? So starting to use AI to augment people where it's firmly people are in control. And then as the community starts to get more comfortable, we think you're going to see more desire to integrate the technology in a more fundamental way, in an automated way, right? So I think that's about building trust and confidence. But over time, if you want to automate decisions, as you should, right, and have it in a decentralized way, then you will want to have blockchains with smart contracts that could link out to AI capabilities. I think one thing is a lot of times the Web3 community tends to take a view that there's either perfect highest security blockchain level of decentralization or there's nothing. And I think that really you need to relax that and say, hey, you need to have a decentralized stack for Web3. And so if using a zero-knowledge proof is the highest level of security, it's also the highest overhead. And as I was mentioning earlier, you're probably not going to want to use that for everything. At the other extreme would be an optimistic approach where you can run an open source model. You could run it in a network, as Kamal was talking about. You can have many compute providers that could let you run that model. If you just have the compute provider sign the computation, you can at least have a form of tamper-proofing with optimistic tamper-proofing where it's low overhead, but you could go back and say, hey, you've now got non-repudiation. You can go back and say, no, actually, you didn't compute this correctly, and you could slash the person who did that calculation if they put stake, right? And that's another extreme. In between, you could have a consensus mechanism, right? So much like with Chainlink functions, where you run the same function many times, and make sure by running it several times that you come with a consistent result. In the details of like how close can it be given floating point calculations, it's probably not an exact match, so it's a little more complex to get that kind of pessimistic version working. But I think there's going to be uses of all of those over time, so different ways of doing the decentralized calculations. And I think decentralizing the calculation for runtime censorship resistance is just as important as decentralizing the model creation, right? So like already people are worried about a form of censorship, right? So like if you're working with an API provider and they rate limit you, they're censoring you, right? You have a limit on what you can do. I don't know any AI startup that isn't worried about things like rate limits and performance and access to GPUs, right? I mean, it's a big problem, right? It's a form of censorship. And likewise, if your model provider capriciously changes the model, they're worried about problem X and it breaks your application, they just censored you, right? So people want to take control of their own destiny with where the models are running and how the models work.
I think Ron's going to build a governance bot that votes on chain automatically to protect his bags.
Sounds like a wonderful idea. So at the beginning of all this is data, right? And so Alex, how important, in your opinion, is data traceability and model lineage in this new AI landscape?
Yeah, it depends on the use case or the application environment. Like really, the more you start to deal with big sums of money, the more you start to deal with regulated enterprises or just the pipes of the traditional financial system, you basically can't get away from, understanding the logic or the code or the process by which you came to that output. I like to say in meetings like, there's a culture in New York, let's say, where people get fired, people lose their job, people lose billions of dollars, firms explode when they get the data wrong. And so that creates this kind of inherent cultural paranoia around the outputs of these processes and understanding the inputs and all the steps along the way. And I think when you're a technologist or you're someone who likes to automate things, you can kind of try to look through this and say, well, wouldn't it be great if all the bots did this? But anyone who's been in an audit review or a trade debrief when you lost a bunch of money knows that the more complexity, the more kind of black box your model, the more pain on the other side when you're trying to figure out what the hell happened and why you're losing money. And so we think that that's a pretty core principle, at least to what we do, which is pretty much everything that you can make transparent or the capability of making transparent, you should. It does add complexity to the system. It does, prevent kind of some levels of automation. But when you're talking about, going from a project to a firm to an institution, you really can't get away from it. And so the understanding of even, with regards to using things like OpenAI, like how is it making this decision? Where does it come from? We really like the approach of, use intelligence from machines, but don't make it something that's so opaque that you can't understand why. Make the machine write down why it's making that decision. Make the machine generate a model that you can then have a human interrogate. Because if you go to Jane Street or you go to AQR or you go to one of these big funds, whether they're doing crypto or not, the person who's actually on the line for that risk, you can bet your bottom dollar that they understand where it's coming from. They're ready to go in front of, Ken and Griffin or whatever and explain why it happens, because if you can't, you don't have a job anymore. And so this is that trade-off that you kind of inherently have, and luckily it looks like the more intelligent machines are getting to the point where they can do that. If you think about things like Copilot, it's writing code for you, that kind of thing. And so rather than just automation that executes, automation that kind of explains, provides logic that can be interrogated is, we think, kind of the real path forward in real world use cases.
Yeah, makes sense. And there's a whole, explainability for AI is a huge deal. And it's just a little stretch to getting to verifiability, where you say, okay, if it's explainable, since you write it on chain, so you can't change your explanation, basically.
Yeah, you can't, in a traditional financial services, you cannot say the robot told me so. Like, it's just not a viable answer. Like, even
work.
the most quanti place in the world, you say, oh, my model said so. It's like, well, great, like, you lost money, what are you gonna do now? And you're like, well, the model said so. It's like, you're dead, game out, game over, next player.
But the explainability for AI has really lagged the capabilities of models, right? I mean, people who are doing research on that are trying to figure out really basic aspects of where does the information get stored in this network and how could we change it? But holistically, the way these systems work is still quite a black box.
Absolutely. Well, you could say it's the autonomous agent that did it. Maybe it's a little better than it's the AI. So, speaking about autonomous agents, Humayun, can you tell us more about what role you think they will play in decentralized autonomous ecosystems?
Yeah, so if you think about now, we've dealt with the data, we've dealt with the training. I'll come back to kind of some of the explainability elements. But if you now want to go and actually implement and execute something, then you need, if you look at the older, the more centralized model, you're looking at microservices architecture. And if you convert that microservices architecture into a decentralized system, that's what autonomous agents are. So what you're doing is, we split it into two things. Autonomous economic agents mean there's an economic incentive somewhere in the whole process, and that agent is made up of micro agents, which are microservices. Now anybody could create, because we're thinking about this open system, anybody could create a microservice. So you can create a payment microservice, you could create a query microservice, or you could create a inference model microservice. Ultimately, what would happen is that an autonomous economic agent has to orchestrate and put it all together, and then deliver the final service. So that's kind of the architecture we have in Fetch. So you could bring explainability, and you could say, okay, I'm going to query this micro agent, which tells me if the data was correct or not, before I'm going to take the next step. So the orchestration is then kind of put on chain, but ultimately to bring a service together, you need to have micro agents who put it all together. So effectively, in an old paradigm, these are microservices which anybody can build. They're open, and you can register. And when you're building a final service, the autonomous economic agent goes and picks the right micro agents and builds the service and delivers the service. So that's really the overall view of what the agents are, what the agent framework does.
Makes sense. But is it kind of a big, so it creates an assembly of smaller black boxes? Do you think we will need to push this a little further to get to solving the explainability?
That's a valid point, because if you think about trying to explain a bigger model, it's a lot harder. But if you build smaller, kind of more atomic models, then you can actually explain them better. So our thinking is that if you have a lot of machine learning models which are smaller, which is what we said, the explainability is quicker, and then you enable people to actually put them all together, as a consequence of that, you'll come to a more auditable service delivery, and you'll be able to audit the whole process much better.
I mean, I wonder about that. Like, a lot of people try to explain deep learning systems by saying, hey, I'm going to take some final simple classifier and put together these inscrutable pieces, and I'm going to answer it in terms of, I've got a model for risk and a model for upside, or maybe I've got some embeddings over here, and say, well, now, the final model just composes these things, and people will be like, oh, okay, I get it. But it's like, no, you don't. You just reduced it one step, but you still have these unexplainable components underneath, right? So, you have this choice. You can use better understood simple things, but they're not nearly as powerful, right? Like, we can't achieve anything like what deep learning transformer systems can do with really well understood white box systems. But then, you really can't give a deep explanation of how a transformer model works.
Right, you get this phenomenon.
But that will change, right?
I hope.
That will change, because ultimately we've only at the beginning of the journey. So as you progress, your smaller models are going to become more powerful. I mean, you could see that in Llama, in all the others. The parameters are coming down. The explainability is improving. So if you run this course for another 3 to 5 years, with the compute where it's going, with all the chips, the GPUs that are coming online, you expect this to improve, right? It's not going to stay here. So I agree with you that yes, it's you do need to have all these transformer models more explainable, and you do need at the moment a lot of compute, but that's going to become easier and easier.
Yeah, you can tell it's happening when you need to create a human-labeled model to explain the black box model after the fact. And you go, well, I think it's doing this because of these 3 things. And I'm going to go remodel it to kind of show you that it tracks. And then you're backing into the robot or whatever.
I mean, I'm more optimistic about scalable oversight techniques that don't require sort of going into the internals, because like a small Llama model at 7 billion parameters is really big compared to, like, not so long ago people thought BERT was a big model, and it's 20 times bigger, right? So the definition of small keeps shifting on us.
Yeah.
But instead, if you can do things like have agents debate each other, right? They check each other, or use constitutional AI to like take a principle and validate that what an agent did is correct. I think we'll get further by that kind of checks and balances that then roll up independent information that we as people stay in control of. I think we're going to go farther with that. I mean, I really do hope that things like mechanistic interpretability make progress on deeply understanding the way AI works. But when we rely on other people, we don't put a neural transmitter into their brain to figure out if they're telling us the truth and where they're coming from. We have to use external evidence. And I think we're going to end up relating to AI in the same way.
we see this bifurcation of models getting smaller and more fine-tuned and with more explainability, while models get, into the hundreds of billions, probably trillions of parameters in the next 2-3 years. Like GPT-5 is not going to be explainable. It's just going to be a complete black box. There's this joke that AGI is not going to be a single GPT-5 agent. It's going to be 6 agents in a trench coat, or 3 agents in a trench coat together, right? You have a GPT-5 agent interacting with a, who knows, question mark agent that will come up over the next 2 years. And those two together in a trench coat will be AGI, which creates even more of a black box. Imagine trying to explain 3 models and their combined output.
Yeah, it's really interesting. I like your point about explainability for humans. If someone tells you this is the conclusion I reached and you want to explain their conclusion, you're not going to look at the neurons in that person's brain. You're going to just ask that person questions until you become convinced.
Elon will. He'll look at my
Elon
neurons.
will, but
that'll be a future Tesla interview. Sit down for the neural implant.
Yeah.
But yeah, you go through interrogation. I mean, in a positive way, not actual interrogation techniques, but you just ask questions until you get convinced that, yeah, it sounds like this person did followed a path that made sense.
Are you sure about this answer? Are you sure you're correct?
Well, actually, has anyone tried to ask ChatGPT, why did you come up with this answer?
All the time.
Yeah, and is it convincing? Is it able to explain convincingly?
It just changes its answer.
Do you like this answer? Do you like that answer?
One thing definitely about GPTs is it can tell you a big lie, but it'll explain that lie very well. So you'll probably believe it.
But
it lies quite well.
People do the same thing, right? In neuroscience experiments, when people have been had a brain implant and they make them move their arm, then they say, well, why did you move your arm? And they come up with a story and they believe it, right? They believe they had volition and did it, even though, no, actually it's because we made you do it, right? So GPT does the same thing, and it's probably, you have to prompt it in the right order, right? Like if you've heard of chain of thought, if you say, think step by step and then answer, you get much better answers than say, tell me what it is and then give me how you derived it. It invents a story and it's a worse answer.
Yeah.
Makes sense. So to close it out, we've talked about concerns over centralization, and so do you? And this is a group question. Do you think it will be sufficient to use open source to address these concerns? And if not, which is where I guess this is going to go, does blockchain help solve any of these issues?
Humbly, I'd posit that GPT-5 is going to be light years. It's going to be another step function from, Llama 3. So we see this rapid advancement in open source models right now, and we hear this harp on social that, oh, well, the open source world is growing so fast, and GPT-4 is getting nuked or nerfed or whatever your word is. GPT-4 is getting dumber while Llama 2 gets smarter. I humbly say just wait. I mean, the next step function in that model will be 10 times the parameters and 10 times the black box, unfortunately, but 10 times the quality. And I think open source will struggle. However, like I said at the beginning, we're pleasantly surprised to see a lot of enterprises already thinking about training or at least fine-tuning an open source LLM on their own private data, because they don't want to send private data over the WAN to an API externally and have that very sensitive, often financial sensitive data owned and operated on by a third party. And so as Llama 2 turns into Llama 3 with 70 billion or 700 billion parameters instead of 70, and GPT-4 turns into 5 with a trillion parameters instead of 100 billion or whatever, there'll be a bifurcation where GPT-5 takes off, but enterprises don't care because they're like, hey, Llama 3 is decent, gets the job done for my use case, and I can train it on private data, have it locked down in my Azure tenant or whatever it may be, and run it privately.
Yeah, I think that's a fair point, and but I think one thing we need to do really is to have this hardware infrastructure in place. If we want open source to do well, I mean, at the moment, I'm sure people who are aware of this, the H100 price is just the compute has doubled. in the
Same
last
price as my house or something.
right. It's doubled in the last 1 month or 2 months. So if that carries on and we are relying on open source training, then that's not going to happen. So we need to find a solution so that people can actually, even universities can actually are able to train something which other people who are not part of this corporate group can actually use. And unless we build that infrastructure for financial infrastructure, I think open source will struggle.
Yeah, I think if you're a fan of decentralization, AI presents a big challenge, right? There's clearly increasing returns to scale. GPT-5 is going to be better than GPT-4, et cetera, et cetera. There's clearly a desire to homogenize or coordinate around certain interfaces, certain APIs, certain consistent frameworks. And then the doomerism that we're kind of all being exposed to, the response from governments and the private sector is to centralize. You need a license, can't do this, can't do that, and that's a big challenge. And I think that it's kind of even just culturally nice how you get this tension between crypto and AI around, well, no, like we believe in decentralization, we believe that it's more efficient in the long run, we believe that open source will find the niches that the big models don't, and that you have to hope that that's kind of some sort of competitive balance between those two forces plays out.
Yeah, I think you on that last point. I think it's important that you can have a responsible mode of release to address risks in open source development, right? That open sourcing doesn't mean releasing things without sufficient testing and consideration of consequences, but the centralization risks are meaningful too. I mean, it's interesting, like we've accepted Meta's framing of Llama as open source, but it is not an open source license, right? It explicitly excludes their competitors, which is about as not open source as you can get. It's more open, but I think the bigger question is going to be, where is the funding going to come, right? It doesn't matter, like the hardware does cost a lot, right? Training a state-of-the-art model costs $50 million, right? Who's going to pay for that? Right now, Meta's doing it for strategic reasons, building a more open model. There are efforts, governments like the French and British governments have funded independent consortia. It's possible that, and I think where the big opportunity in Web3 lies is that you can have self-sustaining open source ecosystems, right? That you can have protocols where there's funding that can allow the community to fund what it needs, right? And so if we can harness a DAO to provide ongoing funding for responsible open source AI development, that could really be a superior alternative to relying on centralized big AI to keep funding the development of models for their own purposes.
Maybe to really quickly bring it full circle back to the intersection of blockchain and AI, I think you almost have to envision this near future of a wealth of autonomous agents that are have their own private key, that are interacting natively with the chain, making decisions, trading crypto autonomously for their own purposes and building wealth for their own uses. And I've been really impressed by Chainlink's vision of just make it really easy for external agents to connect to the chain in a decentralized or at least trust minimized way. So imagine having this near future that to some might be dystopian, to me is utopian, of a plethora of autonomous agents just making decisions on chain through Chainlink.
Thank you. So I think we're just at time. So this has been a fascinating discussion. Thank you. Sounds like we're gonna all do a DAO, fund it, and create and compete with the big centralized AI.
Let's do it.
That's the outcome. No, joking. So thank you again for being here. Really appreciate it. Thank you.
Thank you.